Okay, here we go. So today we are solving, Today we are solving multi-step linear equations. No, nobody saw my password.
Yeah, it was star.
All right. There we go. Okay. Here we go. This is it. It's kind of nice. So example 1, solve the equation. I wonder if that's a typo. Solve the equation. Solve the equation. So when we're solving the equation, we are solving for the variable. And letter A, the variable is r. So we're solving for the unknown, trying to figure out what that number is that makes that equation true. And I'm sure you all know what to do here. We have negative 3 times the quantity 1 plus 6r equals 14 minus r. What do you guys want to do first? Distribute, sure. I'm going to distribute that 3. When you distribute the 3, negative 3 times 1 is negative 3. Negative 3 times 6r, negative 18r. Very good. Equals 14 minus r. And then what do you want to do? Okay, so I'm hearing we want to get the r's, collect the r's, right? They're friends. They need to be on the same side. Technically, it doesn't matter which side you move the r's to, but the strategic way I was hearing was, hey, let's make our result positive. So I'm going to add 18r to both sides. Now, do you need to show this step? God, you don't. You really, really don't. I'm going to do it in notes, but it's really not necessary. Of course, the most important thing is that you get it right. Okay? Negative 1r and a positive 18r gives me what? 17 r's. Okay, and then what do you want to do? Subtract 14, subtract 14. So positive 14 and negative 14 go away. Negative 3 and a negative 14 is negative 17 equals 17 times r. And how do we get r by itself? Yeah, the inverse operation, the inverse property of equality says I can multiply by the inverse, which would be technically multiplying by 1 over 17, which is the same as dividing by 17, the multiplicative inverse, which means that 17 over 17 reduces to a 1, and negative 17 divided by 17 is negative 1. So our r value should be negative 1. How do you check your answer? You plug it back in, right? So that's easy to do. How many of you have graphing calculators? Hey, get your calculators out. I'm going to show you something totally wicked. The wrong calculator? Like, it was like a scientific, not a graphing calculator? Oh, yeah. Oh, got you, yeah. Funny. Okay, here we go. So, if you have a Casio, then it's menu driven, and you're going to press menu, and there's a graphing menu. So you're going to arrow over to that graphing menu. And depending on which screen pops up, hopefully you see the y equals screen. Is that what you're seeing? I know. And then here on my TI, you go to y equals, and that is the graphing menu. And so I'm going to delete this F1. There we go. Okay. And so what we're going to do The best way, and this works, ladies and gentlemen, listen up, to solve any equation in the world, you put the left-hand side in y1 and the right-hand side in y2. And of course, we're not going to use the letter R. Your calculators just have an X button, so we're going to use X's. But you put the left-hand side in y1 and the right-hand side in y2. So I'm going to do that. I'm using the negative button. Make sure you use the negative button. -3, quantity 1 plus 6x is right here next to the alpha key. Yes?
Does it still work if you have more than one variable?
No, that's true. If it's an equation with one variable. Okay? Now, we can do it, let's see. No. So the difference is we have another way to solve if there's more than one variable. All right. Over here, same thing. So I'm going to type in -3 quantity. My x on my Casio is xt and theta. I don't know if you can see that. It's right about here below the alpha key. There's the x. Oh, not x. Sorry, that's a typo. 1 plus, no, that's a minus. Plus 6x. There it is. Okay. So we got equations in y1. I'm going to put the other side, 14 minus x, 14 minus x, and 14 minus x. All right. You'll notice, you see the similarities here. Both equal signs are highlighted. That means you're going to see the graphs. Okay. And so we want to do, I'm going to say for the TI, zoom is a great button to know. You're going to do zoom probably standard. Zoom standard. This is a standard window, so zoom 6 is a standard window. And that's going to graph that on a regular 10 to 10 window. Okay. On the Casio, we're just going to press draw, I think. Yeah, okay. And so it sort of picks a window, I think, for the Casio. I haven't quite figured out. Oh, wait, zoom. Let me try that. Okay, sorry, auto. Let me try that. Oh, that's kind of interesting. Kind of interesting. Different pictures, right? It's because they have different windows. What we're looking for is the intersection. On my standard window here with my TI, I see my line coming up like this. It's a negative slope line, technically. And then we have this slanty line going this way. They're going to intersect somewhere over here. What I need to do is I need to make my y-axis taller. To make my y-axis taller, I'm going to go to Window. And I'm going to change my y maximum to something larger, like, I don't know, 20. So go to Window and change that maximum y value to like 20, and then hit Graph. On my Casio, I used the Auto Graph feature. I had a zoom. Do you see in yellow? I have it in yellow. It's a second function, so second zoom. It must be 138. Alarm. Okay, so you can't use that. You can use that X right Change your mind. No, it's the room in the back. All right, we'll get this worked out more. I'll talk more about this. Anytime you're solving an equation, you're looking for where those pairs intersect, and that's the solution for x, the x that works for both sides, okay, or in this case, R. On my Casio, I use the auto graph feature, and these two lines intersect right here. On the Casio, there's a gsolve. It's a second function, gsolve, graphing solve. So I'm going to do shift, graphing solve, and you see root, max, min, y-intercept, intersection. I'm going to select intersection, and it tells me, look at that, intersect, and look, what's the x value?
-1.
-1. What did we get for our answer? -1. Okay. On the TI, it's a little more complicated. We have a calculate menu as a second function. That's where all the calculations happen. So we do second calc, and we have value 0, minimum, maximum, intersect. So we would choose intersect as well. And you'll notice Tinkerbell. Tinkerbell is the flashing cursor. Do you see Tinkerbell? I'm going to use my left arrow key and move Tinkerbell right close to that intersection. The TI isn't as smart. It has to be told where we're looking for it, okay? So I'm going to use my left or right arrow key to move Tinkerbell to that intersection, and you have to press enter, enter, enter. And there it is, -1. Okay? So on the TI, you go calculate. That's right, so hit enter. Yep, hit enter. Enter. Enter.
How many entries? Oh, I just deleted it. I messed up somewhere. There it is.
Yeah, okay, good. All right. So, ladies and gentlemen, I have a question. Here's my question. We were solving for x, or, you know, it was really an r, but whatever, the letter doesn't matter. And we have this x value of -1, and you'll notice that there's these y values of 15. So I'm kind of curious where that 15 plays in to my equation. So when you check your solution by plugging it back in, -3 times 1 plus 6 to the times -1 is supposed to equal 14 minus a -1. When you check, you plug your answer back into the original, and then all you do is simplify the left side and simplify the right side. You evaluate it. So we have -3 quantity 1. 6 times -1 is -6, so 1 minus 6. And this would be -3 times -5. And what is -3 times -5? 15. And over here, what is 14 minus a -1? 15. There's where the 15 comes from. So it's interesting, when we're solving for the x value, the independent variable, that gives us the same output. Okay, we're finding the input value that gives us equal output values. All right? Input, output, ordered pairs. Okay, I love showing that. I think it's really cool. Okay, so let's do the slightly harder problem. What do you want to do first? Put it in your calculator. Yeah, okay. All right, so we're going to go ahead and distribute 10 times x is 10x, and 10 times 3, positive 30. What do we need to do here?
-1.
Oh, I heard a -1. Very good. And then you distribute that -1. That's a great idea. So -1 times -9x, positive 9x. -1 times -4, positive 4. And then this is weird. What do I do with that?
You
Combine them. Good word. I like combine. -5 and a positive 3 is -2. All right. On the left-hand side, what should we do? Combine like terms. Combine like terms. So 10x and 9x. 19 x's. And positive 30 and positive 4 is supposed to equal x minus 2. And then what do you want to do? Get the x's on one side. Can I do that? What does it mean if I just do an arrow like that? Yeah, move it over.
But that would not, it wouldn't be balanced.
It's so yeah, so I'm doing it in my head. Can I do it in my head? Oh yeah? So I'm gonna subtract x to the other side. Can we do that in our heads? Okay, so if we subtract the x, that's gonna give me what? 18 x's. Alright, I'm gonna do the same thing here. Moving that 34, I have to change the sign. So subtracting 34 to the other side gives me negative 36. And then we can do what? Divide by 18 and x equals. Good. I think that's right. Okay. Do you guys have any questions?
No.
Right? Okay. Oh, by the way, I just